this example here. The question said minus cos theta plus sin theta is equal to 1. Okay, so we know that from here, our left hand side here, we don't have any other formula to simplify this. This is the mixture of cos and sine. Alright, so we need to use the final method that we have discussed just now. So let's see here, minus is in front. Let's rearrange so that it's easy for us. So this is sine theta minus cos theta is equal to 1. So now let's see your formula list. Which one of the formula will give you the structure of sine minus cos? Alright, so you can see that this is it. This is sine minus cos. So this is sine A minus B. So let's write this as R sine theta minus alpha, where your R and alpha are the unknown. Alright, so let's rewrite here, your left hand side here to be R sine theta minus alpha, equate it to your right hand side equal to 1. So let's keep this first. Now let's see step 1. Let's substitute our left hand side. So sine theta minus cos theta is equal to R sine theta minus alpha. So now let's expand this. R in bracket sine theta cos alpha minus cos theta sine alpha. So we have finished step number 2. Now let's see step number 3. Let's compare. So let's compare our left hand side here. This is the first term. Okay, this is sine theta and this is sine theta. So this is the coefficient 1 is equal to R cos alpha. Let's compare the second term here. So the coefficient for cos theta here is 1 and the coefficient for cos theta here is R sine alpha. So 1 is equal to R sine alpha. Now we have finished comparing. Let's rearrange. Cos alpha is 1 over R and sine alpha is 1 over R. Now let's see step number 4. We want to find R using the Pythagorean theorem. And let's find alpha using the formula of inverse tangent modulus B over A. So this is the R that we are talking about because you have the triangle in your first quadrant. So cos alpha is 1 over R, your sine alpha is 1 over R, alright? So your R is modulus 1 squared plus 1 squared, this is cert 2. So we can find alpha, the next step, by using the formula here, or we can just rearrange equation 2 divide by equation 1. Alright, so sine divided by cos is tangent alpha. So this is equal to 1 over R divided by 1 over R. This is just 1. So your alpha right now is 45 degrees. Now let's see step number 5. Let's substitute the value of R and alpha inside the equation that we have just substituted in the first step there. Okay, so R sine theta minus alpha is equal to 1. Let's rewrite our R, which is at 2, and our alpha is 45 degrees. Now let us solve this equation here. Let's bring set 2 here. So now you have single trigonometric that you can solve. So sine of theta minus 45 degrees. So let's take all of this. Let's solve this. Is equal to 1 over set 2. So let's find our reference angle. Shift sine 1 over set 2. So your reference angle now is 45 degrees. So let's draw the quadrant here. Sine positive is in quadrant 1 and also quadrant 2. So let's write the terminal line here and put in your reference angle 45 degree and 45 degree. Now let's read your angle here. Theta minus 45 degree. This is equal to, the first one is 45 degree. The next one is 180 degree minus 45 degree plus 360 degree K. So now let's move on. Let's solve for this one here. So theta minus 45 degree is 45 degree plus 360 degree K. Another one is 135 degree plus 360 degree K. Don't forget K is integer. So now final step. Let's solve this one for theta. So you have minus 45 degree. What you can do is just bring it to the other side to solve it. So let's plus 45 degree on both sides here. Okay, so now let's solve this goes with this. Add them up. This is 90 degree plus 360 degree K. And let's solve this one here. This is 180 degree plus 360 degree K. So now this is your general formula. So let us solve for one cycle. So let's put K is equal to 0. So your answer is 90 degree. Another one is 180 degree. So this is your final answer for this question here. So that's the end of 1.6 and also the end of our chapter 1. Assalamualaikum warahmatullahi wabarakatuh.